guys, welcome back to TechDose, and in this video we will look at check if a parenthesis string can be valid, which is from Leetcode number 2116. Some of the related problems I have already mentioned below, and I have already made a video on valid parenthesis string problem 678. So you can find the link in the I button and also in the description below. Let's now read the problem statement. In this problem, a parenthesis string is a non-empty string consisting only of opening and closing braces. It is valid if any of the following condition is true. If it is empty, then it is valid. It can be written as AB, where A is a valid parenthesis, B is also a valid parenthesis. In this sense, you can say that A is, let's say, opening and closing braces, which is valid, and B can be something like, let's say, 2 opening braces by 2 closing braces. So if you concatenate them, then you will have an opening closing brace and then 2 opening and 2 closing braces, which will be valid, right? So if A and B are already valid, then you can just concatenate them and it will be valid. And it can be written as only A, where A is a valid parenthesis string. So if I just write this A, then it is valid, or if I just write B, then this is also valid, right? So you are given a parenthesis string S and a string logged, both of length n. Logged is a binary string consisting only of zeros and ones. For each index I of logged, if logged at I is 1, you cannot change the bracket of S at I. So if the value here in the given example, let's say at index 1, it is in the string S, it is a closing bracket, and if the logged value is 1, then you cannot make it an opening bracket. You cannot switch. Whatever is given is final. But if the value of the logged at index 2 is, let's say, 0, then in this case, even though there is an opening bracket, you can still make it a closing bracket if you want to make it. So that is what the logged is telling us. Return true if you can make S as a valid parenthesis string. Otherwise, we need to return false. So if I can just simplify the problem statement, then it is giving a parenthesis string, and we have to find out, given the logged values as well, if I have the freedom of switching the brackets wherever the logged value is 0, can I make this parenthesis string S valid or not valid? Okay. Now, having understood this entire problem, if you consider switching the value, then wherever the logged values are 0, what you can do is you can try two possibilities. So you can either go with a closing bracket or an opening bracket, right? So for every 0, you will have two possibilities, opening and closing, right? So if you follow this solution by recursion, then you might end up with a 2 to the power of n solution. And if you end up with a dynamic programming approach, then it will be somewhere around n square. But we will not be doing that, because if you look at the constraint, then the n value is already 10 to the power of 5. So this is already saying that if you solve it by n square, it will be 10 to the power of 10. And we know that 10 to the power 8 is 1 second. So we need to do something better than 1 second. And definitely the solution must be a greedy solution, right? So from here we get the idea. Okay, now let's try to understand some points before we actually go to the solution. So first, let's see how to build the balanced parenthesis. So if I ask you build a balanced parenthesis of length 1, what will you do? If you put an opening bracket, is it balanced? No. If you put a closing bracket, is it balanced? No. So you can never make a balanced parenthesis of length 1. It is impossible. If I give you length 2, then how do you make a balanced parenthesis? There is only one way. For the first position, you cannot put a closing bracket. You have to always put an opening bracket. So you should always remember that whenever you are filling from left to right, the number of opening brackets must always be greater than equals to the number of closing bracket. And this you can easily learn by solving this problem, generate parenthesis. Okay. So this is true. And if you move from right to left, then the opposite is true. The closing bracket must always be greater than equals to the opening bracket, right? So we will be solving from left to right, let's say. So we will first be putting opening bracket. Now for the second position, we have to put a closing bracket so as to balance the opening bracket. And so we have formed a valid parenthesis. Now if you consider about length 3, I can put an opening closing bracket, but for the last one, whether I put an opening or a closing bracket, it does not make sense. It will not be balanced. So a balanced parenthesis is never possible for length 3. And you can conclude that if n is an odd value, then a balanced parenthesis will never be possible, because In order to balance an opening bracket, you need a closing bracket, and in order to balance a closing bracket, you need another opening bracket. So the brackets in the balanced string will always exist in pair. So whatever is the value of n, it will always be even, right? So odd length balanced parenthesis is not possible. So this you can do as a step 1 check. If the input string is of odd length, then you can say that the balance is not possible. So you can simply return false. So if I have to form a length 4 balanced parenthesis, I can put opening closing bracket, and that's it. So it is always possible to give a balanced parenthesis of even length. If I just give you an even length, let's say a length 4, then I can always give opening closing, and I will get the job done, right? So if the spaces are vacant and you have the luxury of filling it up with either opening or closing bracket, you will always be able to give a balanced parenthesis. For odd length, it will never be possible. So this is step number 1. Now let's find out, given a parenthesis string, if it is balanced or not. So simply you can use a stack, and in this case I will be parsing from left to right, and whenever I see an opening bracket, I will push it on the top of the stack. So if I see an opening bracket, I'll push it, and if I see a closing bracket, then the top of the stack will be popped out. And if the stack was empty, then we have more number of closing brackets, so that means this is not valid, okay? But this is valid. We have an opening bracket, we removed it. Again, if we see an opening bracket, I will push it, and when I go to the end of the string, if it was a perfectly valid parenthesis, then actually the stack would have been empty. But this stack is not empty. If this stack is not empty, then that means there are more opening brackets than there are closing brackets, right? And if you had seen a closing bracket and the corresponding opening bracket was not present in the stack, if the stack was empty, then this means there are more closing bracket than the opening bracket on the left side, okay? So this is how you can determine if a parenthesis string is valid using the stack approach, and this will take order of n space complexity and order of n time complexity by doing one parsing over the entire string. So this is the suboptimal solution because it is taking extra space. Now let's look at an optimal solution to do balance check. Well, in this case I am taking the same example. You can either solve it in one parse or two parse. Let me first tell you about the one parse solution. So you can simply go from left to right by parsing one bracket after another, and you can keep a counter. So this counter will be 0. Whenever you see an opening bracket, then you will do +1, and whenever you see a closing bracket, you do -1, okay? Now when you see an opening bracket, you do +1, and when you see an opening bracket, you do +1. When you see a closing bracket, you do -1. When you see an opening bracket, you do +1. By the end, your count value must have been 0, but in this case the count value is 2, saying that there are 2 more opening brackets than there are closing brackets, okay? So this is how you check for overbalancing of the opening bracket. Now let's say that we had an example where there were more number of closing brackets. So in this case I can start from the first point and my count value will be 0. So whenever I see an opening bracket, I'll do +1. When I see a closing bracket, I'll do -1. And when I see a closing bracket, I'll do -1. Now at this particular point, a negative value indicates that wherever I see a negative value, I have more number of closing brackets till this point than we have opening bracket. So immediately I will be returning a false, saying that it is not valid, because I don't even care if I have opening bracket after this, but the opening brackets must be present to the left side of the closing bracket. If it is present on the right side, it has no meaning at all. So this is how you can do balance check optimally in just one parse using a counter in order of 1 space complexity, but the time complexity is same as order of n. So space complexity is O1, but the time complexity is still the same as the stack order of n, right? But this solution will not be helpful for our problem because it has wildcards as well. So we have to do it by the 2 parse solution, and you will learn at the end why we are doing it with the 2 parse solution, okay? In the 2 parse solution, we will be moving from left to right in the first parse, where I will be checking the overbalance of the closing bracket. So I'll be maintaining the count of opening bracket and the closing bracket as well. And when I move from left to right, whenever I see an opening bracket, I'll do +1 to the opening bracket. And when I see a closing bracket, then I'll do +1 for the closing bracket. At no point of time, the closing bracket should be greater than the opening bracket. This should not happen. It should always be true that opening is always greater than equals to closing bracket, right? And if this is true across all the points, here you have an opening bracket again, If this is true across all the point, that means there is no imbalance of the closing bracket. Using the similar concept, when we move from right to left in the second parse, then I will be assigning the opening to 0, closing to 0, and now we are checking for the overbalancing of the opening bracket, which means that the closing bracket must always be greater than equals to the opening bracket. This should always be true, right? If at any point the opening brackets are more, that means the opening brackets are overbalancing. Now when I move, then I have an opening bracket, and as soon as you see an opening bracket, you check the number of opening brackets are greater than closing bracket. That means opening brackets are overbalancing, and this is false. Whereas if this was not an opening bracket, but if it was a closing bracket, then this would have remained as 0 and the closing bracket will become 1. Again you see a closing bracket, this will be 2. You see an opening bracket, this will be 1. You see an opening bracket and this will be 2, right? So if there is no overbalancing of the closing bracket and if there is no overbalancing of the opening bracket, then it means that the parenthesis string is already balanced. Okay, so the two-parse solution says about balancing after doing left to right parsing, checking for the imbalance due to closing bracket, and doing right to left parsing by checking the imbalance due to opening bracket. And this will be something we will be using in this solution, and you will be figuring out in the next few steps why we are going for two-parse solution and not one-parse solution. In our problem statement we had wildcard, so let's now learn how to handle the wildcard. A wildcard is a locked value where the value was 0. So it does not matter if it has opening or a closing bracket, because I can switch it and I can place whatever I want there. So let's say that our question is having opening, closing, opening bracket where there are two wildcards. Now whenever we solve the problem, then I will treat this wildcard as if it is not even existing. Okay, so the question will change to a blank space followed by a opening bracket, closing bracket and a blank space, because initially I had said that if you have blank spaces, then you can always put whatever I want. If I want to balance the closing bracket, I'll put opening bracket, and if I want to balance the opening bracket, I'll put a closing bracket. So the wildcards will be kept as blank, but I will just be keeping account of the wildcard. Again, in example number 2, you see there are two wildcards, the first one and the third one. So this question will be treated as there are two blank spaces with two closing braces. So if I have to balance, then I will put a opening brace here and an opening bracket here, right? In the first example, I would have placed an opening bracket here and a closing bracket here. So that is how I will be balancing it, right? So this is how we will be handling the wildcard. Brackets at the wildcard are of no significance, so we will just be counting the wildcards. Now let's look at the condition of balancing the bracket. So if you are moving from left to right while parsing, if you are moving from left to right, then at certain point, if you found that the number of closing brackets are actually more than the number of opening brackets on the left hand side, how this can happen? If you look at this example, in this case you have a wildcard, opening bracket, closing bracket, closing bracket. So in this case, at the second closing bracket, we found that the number of opening bracket is 1 and the number of closing bracket is 2, right? So this means that the number of closing bracket is more than the opening bracket. So what we need? We need to balance closing minus opening number of closing brackets. So 2 minus 1, that means one number of closing bracket has to be balanced. And for that reason, if I have a wildcard on the left side, that means one wildcard on the left side, then I can always balance this closing bracket by putting an opening bracket there, right? So that is the logic here. Whenever an overbalancing happens, I need to use a wildcard on the left side. If a wildcard is not present on the left side and it is present, let's say, on the right side, then it is of no significance. It is not at all important for us. Okay, so the ordering of the wildcard is important, whether it is present on the left side or on the right side. So as I said, in the first parse, we will be doing left to right parsing to actually check the overbalancing of the closing bracket. And in the second parse, we will be doing right to left parsing for checking the overbalancing of the opening bracket. And for the same reason, if I find that an opening bracket is overbalanced, and you can look at it, this example, opening, closing, if you move from right to left, if you find that there is more number of opening brackets, right, then you should have the same number of wildcard on the right hand side. If the wildcard is present, then I can always place a closing bracket to balance this overbalanced opening bracket. Otherwise, if the wildcard is present on the left hand side, then it is of no significance to balance this opening bracket, right? So this we have to always keep in mind. So since the positioning of the wildcard is important, if we move from left to right and right to left, they have two different significance. Therefore, we need to solve this problem with the two-parse solution. The first parse will be done from left to right to check for the overbalancing of the closing bracket, and the second parse will be done from right to left to check for the overbalancing of the opening bracket. So I hope now it is clear why we are doing the two-parse solution. Now let's look at how to balance using the passed wildcard. So if the given question is like this, we have four brackets. You know that there are two wildcard at index 0 and 2. So we are technically solving. There are two open spaces and we have two closing bracket. So once we move from left to right, just to check for the overbalancing of the closing bracket, then what I will do is I will keep track of the wildcard opening and the closing count. So when I am at index 0, this is a wildcard, so I'll be increasing the wildcard count by 1. Now when I move to index 1, this is a closing bracket, so the closing value will increase by 1. Now the closing value is actually more than the opening value. So how do I know that the opening value will be balanced? Because the wildcard plus the opening value must always be greater than equals to the closing value now. Okay, that is the reason. So 1 plus 0 is greater than equals to 1. So yes, it is balanced. Now if I move to the next one, it is again a wildcard, so the wildcard count increases to 2. When I see a closing bracket, it is again 2. So 2 plus 0 is greater than equals to 2, so it is still valid. Okay, and we are done parsing left to right. So there is no overbalancing of the closing bracket. If I do the same by moving from right to left, then you will see that again I have to reset this value. So the wildcard value will be 0, the opening value will be 0, the closing value will be 0 as well. So whenever I see a closing bracket, the value will increase by 1. Okay, now we are checking for the overbalancing of the opening bracket. And when I see a wildcard count will increase by 1. When I see a closing bracket, it will increase by 1. And when I see a wildcard, it will increase by 1 as well. So there was no imbalance because there was no opening bracket. So this is completely fine. If I take another example and do the first parse, the wildcard count starts from 0, the opening count starts from 0, and the closing count starts from 0. We will be starting at index 0, and this is a wildcard here. So I'll be increasing the wildcard count. Opening bracket count, opening bracket count, and then a wildcard count. We did not see a closing bracket, and since we are moving from left to right, I am checking for if we have more number of closing brackets. So we do not have more number of closing bracket. Now when I move from right to left in the second parse, I will be checking for if we have more number of opening brackets. So when I do that, again I will be resetting the values. Wildcard equals to 0, opening equals to 0, closing equals to 0. When you are at index 3, this is a wildcard, so wildcard plus plus. When you are at index 2, then it is an opening bracket plus plus. Now is it valid or invalid? So in this particular case, when you move from right to left, then the closing plus the wildcard must always be greater than equals to your opening bracket. It is just the opposite of when you move from left to right, wildcard plus opening, and when you move from right to left, it is closing plus wildcard. Okay, because we are trying to now balance the opening bracket. So when you see the second time, the opening bracket becomes 2, and this is where the imbalance is happening. Okay, this is where the 2 is greater than 1 plus 0, right? So even though there is a wildcard at index 0, but this is of no significance because the wildcard was needed to the right hand side of 1, because at 1 we have an opening bracket. So we have to return a false in this case, and for the first case we had to return true. Okay. So I hope you have got some idea about how to balance using the passed wildcard. So what will be the imbalance cases? You can derive from the previous example that the wildcard must be less than closing minus opening number of braces when you move from left to right. For an example, you see that if you have a wildcard here, then in this case, if you move from left to right and if you stop at this index, your wildcard count is 1, your opening count is 1, and your closing count is 3. So at this particular point, when you reach to the third closing bracket, this is where the number of closing bracket minus the number of opening bracket is 2. This 2 means that there are 2 number of more closing brackets than there are opening brackets. So I need 2 wildcards on the left hand side. 2 wildcards on the left hand side. But how many I have? I have only 1. So since the wildcard is less than the number of wildcards needed, therefore this will be returned as false, that it is not possible to balance, right? Now similarly for the second parse, if we move from right to left, then in this particular case the wildcard will be counted. The opening count will be done whenever you see the opening brackets. Closing count will be done when you see the closing bracket. Now since we are checking for the imbalance of the opening bracket, that means overbalancing of the opening bracket when you do the second parsing, then in this case you will see that when we stop at this opening bracket, here the number of opening bracket was 3, closing bracket is 1. So how many closing brackets I need on the right hand side? 2. But how many wildcards do we have? Only 1. So this is the point where the opening brackets are creating imbalance, and that is why we will be returning false. So this is how you check for imbalance while moving from left to right and also moving right to left. Okay. So having known this, let's now look at a dry run of the entire solution. So let's take this string as an example where we have 6 braces with 3 wildcards. Now in this example, I'll be parsing from this 0, and you know that from the first parse I'll be doing from left to right just to check the closing bracket overbalance, and then the second parse will be from right to left. Okay. So the first parse will be checking the balance of the closing bracket using the left wildcard. So I will be maintaining the wildcard count initialized to 0, opening counter 0, closing bracket counter 0. So when I see at 0 there is a wildcard, okay, because the logged value is 0. So the wildcard counter will increase by 1. When I go to 1, there is a closing bracket. So closing value will increase by 1. At every point we have to keep track of, when you are moving from left to right, the number of wildcard must never be less than closing minus opening. When you move from left to right, number of wildcard must never be less than closing minus opening. Okay. Otherwise there will be less number of opening brackets on the left side. So yes, that is not happening here. When you move on the right hand side, you are having an opening bracket. Again, 1 plus 1, 2 is greater than this one. When you move to index 3, again you have a closing bracket. 1 plus 1 again is greater than equals to 2. When you move to 4, it is a wildcard, and again 5 is also a wildcard. So we are done. There is no overbalancing of the closing bracket. The closing bracket at 0, 4 and 5 are of no significance because they are wildcards, right? Now we will be doing our second parse from right to left to check for the balance of the opening bracket. Again I have to reset my wildcard value to 0, opening bracket counter to 0, closing bracket counter to 0, right? So now I will be starting at 5. Here I have a wildcard. So wildcard count will increase by 1. At 4 we have a wildcard. So wildcard counter will increase by 1. Then I have a closing bracket. Okay. At any point of time, you know that the opening minus closing bracket must always be less than equals to the wildcard. That means the wildcard must be less than opening minus closing. This was the condition that I had already explained while moving from right to left. Otherwise it will create an imbalance. So that is not happening here, right? Now I will be moving to index 2, and this is an opening bracket. So the opening count will increase by 1. Again you check opening minus closing is actually less than equals to wild count. So it is fine. I'll be moving to index 1, and again this is closing bracket. Again you check opening minus closing is less than equals to wild count. So it is fine. And this is a wild card. So I will be doing plus 1 to the wild card count. So since I did not find any imbalance moving from left to right and also from right to left, so I will be returning true, saying that it can be balanced. So this is the entire dry run, and I hope you were able to understand it. In this case, we are doing 2 parse solution. So it will be 2 times of n, which is order of n, and the space complexity is also order of 1. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the string with the logged value. So I am finding the size of the string, and this is step 1, checking about the base case. If the string is of odd length, then it cannot be balanced, return false. Otherwise, if it can be balanced, then we will be doing parse number 1, which is moving from left to right and checking for the overbalancing of the closing bracket. So this is self-explanatory. You can just go through it. This is the imbalance case, right? So if the wild card on the left hand side is actually less than the closing minus opening bracket, that means the number of closing brackets are more than the number of opening brackets and the wildcard combined. So that means the closing brackets cannot be balanced. Similarly, in parse 2, if everything works fine in parse 1, that means the closing brackets are not overbalancing, then I'll be checking by moving from right to left for the overbalance of the opening brackets. So in this case, it is the exact same process, and again the overbalance case will also be similar. And if it is not overbalanced again, that means if the number of opening brackets are not more than the number of closing brackets and the wildcard combined on the right hand side, then it is fine. Otherwise we will return false. So at the end, after checking for both the type of imbalances, I will be returning true. That means the given string can be balanced. So this is the entire code, and I hope you were able to understand it. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.